together as they're developed.
Good, good. So, your name? Colin. So Colin emphasized this practice of bringing together and often very frequently, right? Bringing together sometimes more than once a day, different bits of work, maybe associated with different features, maybe it's associated with extensions to the functionality of an existing feature, new types of performance, refactorings, etc., on a frequent basis, so that they link up rather than being separated for several weeks before they try to link up. So that's a key component. Anyone else want to put forward some features that we associate with continuous integration? And some characteristics of it. Yeah, name? Yeah. Jason. Awesome. Okay, so ongoing testing commonly associated with the commits, or with completing pull requests, etc. So local testing often undertaken before you push it out, as a routine part of the local discipline. And then when you push it out, there's more build testing, done remotely, to ensure that it plays nicely with the rest of the system, for example. Sometimes there's whole suites of unit tests, system tests, but also smoke tests, which basically verify the code base hasn't been so mucked up that it stops the basic features from working in the system. Now you had added something else to that though, beyond that continuous testing. And what was that? Yeah, version release. That's right. So continuous deployment is sometimes put in place, where you have, as you're contributing these components, deployment automatically to test servers, or even in appropriate cases to production code, if it's a sufficiently validated release. Okay, other components we associate with continuous integration. Okay, I'll put up some characteristics, and first is somewhat combining this with discussion of Git flow and best Git practices, but they almost invariably go, well, those best practices on the Git front almost invariably go forward with continuous integration. So one thing is working in feature branches. Are you folks familiar with that? So when you're going to add a feature, and it could be a new bunch of functionality, truly like a new thing you can do, but it could be refactoring, again, associated with performance enhancements, or allowing a memory footprint, or allowing it to better tolerate going offline, or what have you. You work in feature branches that you create for that purpose, right? So bespoke branches I create as a sort of sandbox for building up this feature, and you're going to be contributing to those, but you update one or more times a day from the code. When I say update, what do I mean? I want to make sure people understand. Okay. So I'm actually, I will talk about pushing code in a moment. So that's excellent, your name? True thing. But I'm actually talking about refreshing, doing a pull, to make sure you've gotten other people's changes, right? What you don't want to do is have your code base against which you're developing your code go really out of sync with the rest of the system. Why not? Why not just let it go out of sync and come back with it? Merging is terrible. It's merge hell. Exactly. So when you may get a false sense of security, you're building your code up thinking it's going to work with the rest of the system, but when it comes to actually going and integrating it in. And you're putting together a pull request, you discover, wait, there's all these merge conflicts, right? All these conflicts associated with other people's changes to the system. I may be depending on APIs that have changed, right? I may be depending on components that have been altered since I started development. So we will pull things commonly more than one time a day. And you will have to go along with our sort of regular work, automated builds that can be kicked off through particular actions where you are going to commit or push, but also that can be triggered with a single step, right? Not something that requires configuration. And you're building from scratch. When I say from scratch, what do I mean? Or what am I contrasting it with? Yeah, name?
Ronan.
Roman? Ronan, thank you.
So building from scratch, is what you said?
Yeah, so
Like you're rebuilding the database.
that's right.
Like you're rerunning the database.
That's right. I'm not building based on incremental things that were produced earlier. Based on, a database that's been built up across many steps of my previous workflow. Because if there's a problem, amongst other things, it'll be hard to reproduce, right? You really want to build things not based on incremental compiles that have been done previously. You want to do it based on from a standardized, starting point, which can always be reproduced. Because otherwise, it could just be based on your current system, right? Like what you happen to have in place, and the build may work for you, but it doesn't work for your team. And that's a problem for getting everyone on the same page. Typically, you build with each commit. This is the best practice. Why don't you do that? One build on commit. Yeah, maybe. Yeah. Yeah, that's right. Yeah, I mean, if you're committing, you want to make sure that you haven't screwed up the system through that commit. And if it's a chunk of work that's ready for check-in, you expect it to be buildable. And typically what goes along with that is testing too. And I ask you to adhere here to test-driven development. So you're going to be developers in this class are going to be contributing code. I expect you to contribute test code alongside your feature code for the system. And you're going to be running those tasks initially locally on your own machine. There's going to be typically GitHub runners that will be running them when you actually put together a pull request, and there's a merge of your brand, your feature brands into master. Folks following that? Are you familiar with that notion? You have a feature brand, you're developing it, you're testing it, it seems good. You're going to put together a pull request, right? You're going to get feedback on it from across your team. And they should be able to review the status of your test, what tests you've run against it, to understand what has been validated against, what things might it not have been tested against. And then you're going to be merging it into main, right? Into the master. Are we on the same page with it? Yeah.
I think you mentioned the slide with this, using Gilly Cloud, so you can go down the slides.
That's right. Yeah, it forces you to be mature. It forces you to deal with the problems and not just push them always out till later to deal with. Your name? Rob. Rob. Okay. And we do expect, and this is a really important point for this semester. Last time I taught this class a year ago, we had a team that had recurrent problems because they weren't merging things into master, into main, until close to the deadline. And then it wouldn't convert, right? They couldn't get it working. So they would tell us, like, you know, our system is not on master. You need to look at this branch. That doesn't fly. Like, that is not gonna fly this term. Like, we will not be doing that. Please note, I'll be looking for you to emerge in master and main, and that requires a certain discipline of, you know, frequently updating from the code base so that you don't get way out of sync, and building and testing frequently, and putting together pull requests that merge into main frequently into master, right? And that get feedback, get reviews on those pull requests. How many people here put together pull requests? Okay, so many, but not, certainly, not the large majority. So this is gonna be a discipline you're gonna build up, and it's one of the prime ways that peer reviews are done these days. We talked about peer review a little bit in the remote section. Peer reviews of pull requests are one of the most common forms of peer review that are conducted these days. And you want pull requests that are informative, right? That describe what you contribute, that describe the tests that have been run against it, the motivation for it, and I'll be looking for that in your pull request. Your pull requests for this class need to be intentional, they need to be showing what you're intending to do, you know, what's the motivation for this, what you added, what tests you've run, and confirm that it's been reviewed at some level prior to that. But I want to see those pull requests. Now, before you put together a pull request, you're going to be updating again to get other people's changes, building and testing, right? So your system, what happens if you omit it? What happens if you don't do it? What's that? Yeah, cases. Yeah, it's not. Yeah, exactly. Right? There's a good chance it will break. And there's a chance it will break other people's code, and then it will screw up the code base so much that other people won't be able to do theirs. Right? Yeah.
It's not a very silly question, but why do you do a bunch of questions for a control device? If there's really thing that needs to be doing phone. So how do you detect that it is not in existence?
Well, here you're going to be running a remote, so commonly you're testing locally, right? And you're going to be doing a test on the remote runners here. And it should give the same result, right? For this, but if possible, the build configuration remotely won't be the same as your build configuration. So you at least want to validate that. And ensure that it's going to be consistent. Yeah.
Just maybe a little bit above my head here, but it's going to be like a local remote.
That's right. You're going to have a local configuration. That's right.
Usually, I've just done local before, and then do one download from the locals. Your local contains.
Yeah.
How does that work in this?
Because we're going to have GitHub runners, and this is the way we've done this plan for years. So, are you familiar with GitHub Action? Okay. But you folks have used GitLab before, and you have GitLab runners associated with that. And I'm not sure if those were running remotely. Were those running on remote machines?
You can use runners as part of the.
Oh, okay. Okay, so this class does. We have runners set up, and they're designed to be architecture agnostic. And what I mean by that is we don't have GitHub runners that are specifically Mac OS runners or runners that are only on, you know, Windows. They're machines that can do remote testing, you know, often against regression tests. So this is something will be talked about a lot in my class, but as the project goes on, there are a lot of tests that are geared at any one time for the features being tested then, but there's going to be a growing set of tests whose job in life it is to ensure that bugs that have been fixed stay fixed. And that ensure that features that have been working stay working. And this is a large set of tests called a regression testing. It's the regression test. And, you know, in larger projects, there can be thousands of them. Often the local builds, the local tests, don't run against that regression. But you will, on more powerful remote runners, be performing this testing against a larger set of tests. You may also be performing deployment scripts remotely. You may be undertaking tests against emulators, which you don't have locally, et cetera. And so what goes on when you engage in testing with the GitHub Actions in this case, maybe a superset of what you're testing against locally for your builds. Because one of the elements also of continuous integration is keeping builds quick where possible, so that they can occur very frequently when they come to that. But not every build that you do for that purpose will include all the bells and whistles of a remote build, which may include regression tests, it may include style tests, it may include deployment related activities, etc. So generally, you know, you can have some components of this that are a bit different from the local building. Okay. You're going to be pushing small bits of work, and you know, in industry, the general practice, if possible, is to push these more than one time a day. Now, you folks are juggling this with many other clients, and I recognize you may not be pushing individually more than one time a day, but I certainly would anticipate you contributing elements. Maybe they're tests you're writing, maybe they are bits of code, maybe they are components associated with documentation, etc. At least every couple of days. Right, so I will be looking for that. And you know, for the testers, what they're going to be contributing, maybe things like system tests and updates to the test matrix and updates to configuration scripts for testing. For the developers, it's often be both. Testing to be automated. What do I mean by automated? You know, what am I contrasting? I talk about automated testing. It's contrasted with what sort of testing? Yeah. Are you Tanner? Yeah. Okay. Yeah. So when I say automated testing, I'm talking about testing which could be at a through the UI, but it could be undertaken against the API. Can anyone explain that? When I say testing through the API, what am I talking? Yeah, I think another comment.
Yeah, maybe.
Okay. They have to the same bucket. You sit over here, he's gonna sit over there. Okay. Yeah, okay, yeah.
Like this.
Sorry.
No, it's okay, sorry, wait, what was the question again?
Yeah, so, when we do API testing, how is that different from testing through the UI? When I use those terms.
You're just like hitting the endpoints and checking the data versus actually checking points and stuff.
Yeah, exactly. So if we're going through the UI, it looks rather different for a web-based interface where we might use Selenium, or in older days, Water web application testing in Ruby. You may have heard of that. These days, maybe Playwright, which is another popular web-based testing system. And there it's, you know, essentially you have a browser-based interface that's interacting with the page and pressing buttons and doing drop downs and toggling toggling radio buttons, or putting in checkboxes or filling in fields with text, right? People comfortable with that idea? It's like pretending to be a person, right? For a smartphone, what does that look like, UI testing for a smartphone based system? Yeah, it's interacting with the screen. How does it do that? What technology? So it uses emulator. If I say a virtualization based system, is that? So look, it's emulating a smartphone's operation. Simulating essentially what its memory is and so on in a particularly efficient way. I'm not going to go into the detailed technologies, but there are emulators. I'll be with you just a sec, Conan. There are emulators for iOS and there's emulators for Android, and basically those allow you to run an app in a sandbox environment, like as if it is running on a device, but it's really running, on an external, some sort of machine as part of a virtual machine. So we've got a virtual machine. It thinks it's a smartphone, and it has to deal with things like, what does its camera see, and what's the size of the memory available, but it's through an emulator based method we maintain that. Yeah.
So basically, like specific software where you like straight into the app, would you use like Android or something like that?
Good question. So there's a variety of Android testing environments that are emulator based and that will drive it against scripts. And similarly on iOS, there are standardized ones, right? Because it's a much more closed ecosystem. And I think there's mechanisms as part of Xcode or what have you for the details of the emulator. If you're working with a cross-platform environment like React Native or Flutter, you're operating through some of the mechanisms that offers for testing, and those drive the requisite components for that can test out your system on these devices on a cross-platform basis. This is important because emulators are fairly specialized tools. You don't need emulators for web-based testing. You do need emulators for scalable testing for smartphone-based systems, device-based systems. And those can interact awkwardly with containerization, another virtualization based system. What does containerization give us in the future? We'll have a separate discussion on containerization. Well, what is containerization? Yeah.
Big systems that are purpose built instead of a full system.
Okay, so they're purpose built raw. Yeah. That's a component of it, absolutely. But it has a completely defined, built from the scratch up environment that each time you run it, it'll be exactly the same. And so it's completely reproducible. And it's self-contained, like you were indicating. So it's self-contained. And what that means, and it can run on any platform, right? It can run on Windows, Linux, and on Mac OS. And this is really important because it allows developers on whatever box they're using to have the exact same behavior from your system and not have it be dependent on the vagaries of what libraries they have installed on their particular actual hardware box, what particular version of Linux they're running, what particular version of Windows. Without that, it's configuration hell, because I see a bug on mine that you don't see, maybe even on Windows or on Windows, but you've got Windows X, Windows Y, and I'm not seeing it. And containerization allows us to offer precisely the same configuration environment for testing.
Yes, you can do that scope again. So Like Kubernetes or whatever, like, you can do like.
Absolutely.
Template, well, that's still like considered basic, but like with,
Yeah.
like Vagrant or any of those other like Terraform or something, still the whole VM running with spec. But
Yeah.
there's no like.
That's right, and it's not that Docker is the only system out there, by no means. I mean, there's Rocket, for example, and you're absolutely right that the whole virtualization revolution that gave rise to Docker, for example, has given rise to Kubernetes and a set of other technologies and, whole virtualized servers that also are completely self-contained environments that you can swap easily and configure precisely the same and bring up and spin down, or spin up and spin down. So just be aware, containerization is often used by 371 teams to allow completely reproducible test environments for each system. So that what one person sees on the test team is the same as what the developer sees, as another test team contributor. It's all exactly the same, down to the bit level at runtime, what they see. And that's really important. Just be aware that if you're working on a device like the Oculus, or you're working on a device like the smartphone, those don't always play nicely with containers. They're virtualization-based layers, and they sometimes fun. I'm not going to say you can't do it. There are people who make, Docker containers work somehow with smartphone-based systems or with Oculus emulation, but it requires more care for the but we want automated testing. So I asked, UI-based testing. Connor had talked about it interacting through the UI as if it were a user. But the other type of testing that he spoke about is operating through the API or directly against endpoints, right? And there, it's not going through the UI, it is going through deeper levels of the system, and it doesn't have to deal with UI change. Why not go through the UI always? Too slow. What's another? Yeah. And the truth is, you were asking about scripting environments, right? We've come a long way. It used to be if a button was moved by 1 pixel, it would break. Right? It would be looking for a button at this location and it couldn't find it. Or where it pressed it, the button is slid over to the right and it misses the button, right? Some stupid thing. But these days, our languages in Seleniums of the world or playwrights or what have you are higher level. So that it's less fraud, but still you refactor the UI quite frequently. You divide things into different streams. I spoke about that remotely from Seattle. Okay, you should be logging build and test requests. Test results. So when you run builds, when you run tests, you should have output logs that can be examined. And you should be reporting build status. There's data mechanism for doing this. When I talk about build status, can you clue me in? Like, what am I talking about? Build status. What's the most important dichotomous, binary build status? Yeah. Did the build break or not? Compilation is part of it, but it's not the only thing. For example, the test may fail. The smoke test may fail, which is testing basically the code base that's sane enough for people to pull. But it's not going to screw everyone over by rendering the system unrunnable for the other testers or other developers. It could have failed because of issues with egregious style violations. Could have failed in the attempt to push it to test servers. There's a number of reasons why we may fail, stages of our build, right? Compilation is arguably the, most important of those, but, you know, there's other things that, that can occur as well as part of the build. And that can be key. And so you want to know if the build succeeded or failed. Please, 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 please. Do not let build failures become a rule. If builds fail, it's a bad sign. It should not be the norm for your group. If it's the norm for your group, you know, it's a sign of really problematic development processes. And I will be looking for builds that succeed. And I'll be looking at build status, and I want to be able to see reports on build status. And your team will want to see reports on build status. Why would your team care about build status? Why wouldn't your team want to know? Yeah, maybe. Yeah.
So it's not.
Okay, so that's sort of at a high level. Can you make it more specific? Like what thing could I avoid by knowing this person?
Errors.
Okay, so certainly if I'm a build master, I want to know. Because I want to figure out why the building is. And generally I'm gonna have to rope in like the developer who last you know, got code merged into the system to ask. Yeah,
Yeah, you'll avoid like building on broken code.
exactly, yeah. So, you know, you want to, if the boat breaks, you're gonna want to ask, like, do you want people to still pull from that code base? Because there may be problems with the code base. One may want to even think about a rollback till you can figure out what's going on with this latest merge, right? So you're gonna be wanting to report the build status. When you fix defects, when you seek to fix a bug, you want to make sure that you have a validated test. Now, maybe it already was detected by a test, and that's fine. But you want something that used to fail and now works as part of the test that goes along with that defect. And you want to cross-reference this with an issue. We're going to be using GitHub issues to report problems, system trouble incidents. And you're going to want to reference that issue number when you put in this commit, right? To say this is a fix to this issue, to this problem reported in this issue. So the problem reported in this issue. And you're going to want to test that will confirm that it now works. Where do those tests go? We talked about it earlier. They go into the suite of regression tests. Because you don't want the fix to later reverse itself because someone, you know, splats in code that overwrites the fix. So I've listed here a set of things which are really nice to have features. Automated style text. What do we mean by that? What do we mean by style text? Yeah, it's good stuff. Yeah. Yeah, looking for compliance with coding standards that your group is entering. And there's quite a few tools out there that will look for these things and look for a common. Are you familiar with the term length from 214? Okay, so there's a whole suite of tools out there that have been since I was a young man, which is a really, really long time. With whose job in life is to find not just style violations, not just, you know, you put the curly bracket on the same line as the, you know, but instead of under it, indentate it. But they'll also check things like potentially unsafe calls to certain APIs or unsafe practices with code, use of unidentified variables, etc. So Style checks are good things. They're not nearly as style, they spot potential errors. Because one of our stakeholders is here, I want to turn it over to Wade in just a second. But, two other things that, you know, are really good to have. They're not universal. Automated deployment, to a system, if you have a web-based system. You may have build options that actually push it up to, a test server, or even a production server. There'll be certain build actions that you can configure to push it through. And that would allow you to then, have that as the communication. And test driven development is something that I want to see, different. The final thing I'll just mention before Wade, gets up here is, and Wade, you want to come up and we can, get you set up? Do you have like, how do you want to do this? Do you want to log into the machine or do you want to?
Share the Google slide with you.
Great.
It might be easiest if you just pull it up on.
Awesome.
the machine and Google.
Awesome. Okay, I'll do that while we're setting this up. So, with smoke tests, the job of a smoke test is to make sure that the code base stays sane. And Google Slides, right?
Yeah.
The code base stays sane. And what I mean by that is that the code base is not so messed up that it's gonna do a disservice to people who pull the latest. And okay, so I should probably go to Drive and see what's shared with me, right? That's probably
Yeah, probably.
the best way to do that. Shared. Yeah, there we go. Okay. Okay. Sorry, shared with me. Yeah. So with smoke tests, we're typically putting the system through its basic paces so that, for example, you check, can you log into the system, or the basic pieces of functionality that have been working still working? If not, you need to warn people the build this failed so that they don't pull the latest changes and end up in a world of hurt. Okay, so slideshow. Okay, Wade, I will stop the recording.